Router on a stick. Cool name, huh? In this video, we'll dive right in and see how it can be used to route packets among the subnets that exist on VLANs. Let's do it. As always, I matched the organization of the book. In this case, of the two-book set, it's Volume 1, Part 5, Chapter 18, which has 4 major sections, and the formal name of the first section is VLAN Routing with Router 802.1q Trunks, which everybody calls Router on a Stick. So to mix it up a bit versus the book, I'm going to go straight into the config and verify altogether for the classic case where you're ignoring the native VLAN, avoiding using it, which is a common design choice. And then we'll fold back in the cases where you are using the native VLAN and needing to route for the subnet that exists in the native VLAN. And then I'll combine all the router on a stick troubleshooting into the last part of the video. What else? Well, I said Chapter 18. That's if you've got the second edition book that has that green swoosh on it. Those came out in the year 2024. But if you had the earlier book that doesn't have the green swoosh on it, that would have been Chapter 17. They're effectively the same chapters with some updates for this 2024 edition. That is the second edition. Then finally, stick till the end of the video. I've got extras for those of you that care about the exams. I will tell you what to do with that content in the book now that you've seen a video on the same thing. I'll give you a review activity that's very useful in this case, and I'll give you some extra practice with the command line for router on a stick. All right, let's jump in. First off, what does router on a stick do? Well, you've got a separate physical router from a separate physical switch, say in a branch office this day and age. And you connect them with one physical link, but you want to support multiple VLANs, in particular the subnets that exist on different VLANs. So we're going to use trunking. We're going to configure trunking on both ends of the link, both on the router and the switch. So router on a stick is going to be on one physical link. That's the idea of the being on a stick, if you will. But from a VLAN perspective, we're going to have at least 2 VLANs, or we don't need router on a stick because we're going to route between different subnets, one subnet per VLAN. So we've got PC1, it's in VLAN 101 in this case. PC2, it's in VLAN 102. In real life, there's probably lots more devices in each VLAN, but I just didn't bother showing those to declutter the slide. Then we're going to configure trunking on both sides. And the idea that we're going to configure is that the router is going to be aware of and know about these 2 VLANs. And it's going to have this virtual interface that is somehow correlated to each VLAN, and those are called sub-interfaces with a router on a stick configuration. In fact, here are the 2 sub-interfaces that we'll use. The sub-interface ID starts with the physical interface identifier, which is going to be gigabit 0/0/0 in this example, and then a period, and then a number you make up. It's just another decimal number, dot something. Now, get this. For VLAN 101 in this example, we picked sub-interface 101. It really is a decimal number you make up. So for VLAN 102, you'd think, why don't we use 102? And you could. In real life, I would. But just to make the point that the sub-interface number does not have to be the same number as the VLAN ID, in the examples, I'm going to use another number here, 456. Just to make the point, all right? And I'll show you a few variations on that theme. So that's the big idea that's kind of weird with the ROAS config. So let's start over on switch 1, where we don't really have anything new if you're following the book in sequence. We're just going to configure static VLAN trunking over here on that port and create the VLANs. So to support those devices, we're going to create these 2 VLANs, 101 and 102, and then to enable trunking, switch port mode trunk is a subcommand on that interface. Now, just to emphasize it, there's no dynamic negotiation of trunking supported over on the router, so you must statically configure trunking on the switch. So don't forget both of those steps, all right? Now, once you're done with that on the switch comes the part that's fairly new here, which is the router on a stick configuration. So you're going to pick a sub-interface number, any number, and then we're going to configure the VLAN ID. That's the part that must match. So in this case, in the drawing, it says we're using VLANs 101 and 102. So we'll configure, you guessed it, 101 and 102 over there on the left under the router, and we're going to give each of those subinterfaces an address and mask, just like we would a physical interface before now. All right. So here's the config. First off, the physical interface gig 000, it still needs to be in an up state, but otherwise it does not have any relevant config. In fact, normally you're going to see this default setting of no IP address on the physical interface. Then for these two subinterfaces, which are logical subparts of the interface where we can attach the router on a stick configuration, we've got this new command, encapsulation.1q101. And what it says is we're doing trunking. We're using, of the two types, ISL and .1q, we're using .1q. It's the only one that's available today, but there's historical reasons for that. Encapsulation.1q, and we give it the VLAN number. This is the number that must match the VLAN number used on the adjacent switch. And then, just like any other router interface, we give it an IP address. Now, I didn't go through the planning of IP addresses with you here, but let's just say somewhere else we've planned the idea that router R1 is going to have this address and mask in the subnet that sits on VLAN 101, and this IP address and mask in the subnet that sits in VLAN 102. And all you've done is configure those values here. Now, to complete the discussion of the config, we've got subinterface 456. Why that number? Because I just want to show that this subinterface number does not have to match the VLAN ID. The VLAN ID 102 is the number that must match what's configured over on the switch. That's the important part, if you will. In real life, yes, I would have made the subinterface 102. All right, so there's the config, and it just helps to practice and get comfortable with that. Just to show you that you could have used the more obvious subinterface number 102, here it is in the diagram. That's the same configuration on the router for subinterface 101, and now an alternate config for subinterface 102, also with VLAN ID 102. So that would have worked just as well over on router R1. Now take a pause and think back to what you expect to see on a router in terms of IP addresses and routes, right? You configure an IP address on an interface, you expect to see routes off that interface, in particular connected routes and local routes, right? Now we've got these two subinterfaces that are subparts or subinterfaces of gigabit 000. Well, each of those subinterfaces act like interfaces in the routing table. So show IP route connected shows that subnet ID we configured off subinterface.101, and look, it's directly connected, and there's the subinterface 101. Likewise, off subinterface 456, here's the connected route for that 102 subnet, if you will. So expect to see these subinterfaces in the same places you would have seen physical interfaces before you thought about router on a stick. The other big command that's totally new then for router on a stick is this show VLANs command. Now notice it is not show VLAN, it's show VLANs, and weirdly enough, on Cisco routers, show VLAN and show VLANs are different commands. So for now, show VLANs basically tells us in show command form your router on a stick config. So in that config, we had nothing on the physical interface, but we had two subinterfaces, right? So here's the VLAN ID that we had off subinterface 101. There's the subinterface restated. Here's the VLAN ID restated, VLAN ID restated. So you see spread across here the VLAN ID and the subinterface number showing up throughout this show VLANs command. Now, if you continue on through that command's output, and we've got it configured with this oddball .456 subinterface that I'm using just to make the point that it can be different. You'll see these gray highlighted VLAN IDs of 102, but the yellow highlight for the subinterface number, seeing that, hey, yeah, indeed, we can have that different subinterface number here as well. So you probably want to get used to the show VLANs command, especially when you're labbing this, and make sure you understand the output in that when you're doing those labs. So in this case, let's just say your design called for the use of the native VLAN, and let's say VLAN 101 is the one that we're going to use as the native VLAN. So as a reminder, just good old plain old layer 2 switching configuration. To make use of VLAN 101 as the native VLAN on the switch side, you'd add this command switchport trunk native VLAN 101. So now 101 is the native VLAN. How does that change the router on a stick config? Well, it turns out there's two different ways we could configure R1. So I'm going to start out showing you the one with the least change versus what we just saw, then the one that's completely different. All right. So first off, we've still got a physical interface. It still has no relevant config. There's no IP address there. We still have a .101 subinterface. It's still got VLAN ID 101 configured, and there's one more keyword here at the end of the command, native, which is what you need to configure to tell the router, hey, this one's the native VLAN. Now, as a review, if you don't remember, the native VLAN is the VLAN for which, when sending frames, the device does not add the VLAN header. And when receiving a frame that doesn't have the VLAN header, the device assumes, oh, that's a frame in the native VLAN. All right, so the frames that flow back and forth here without a VLAN header will be considered to be in VLAN 101 now, based on this on the switch and this on the router. The other subinterface config, no change. So that's very simple, straightforward. It's Wendell's personal preference if you're going to make use of the native VLAN because of the two styles. The only difference on the router side is whether you have that native keyword on one subinterface or not. And you have a somewhat familiar command on the switch to configure it. All right, so when you do that, you still have a routing table, but there's really no difference to it. There's nothing in the output of show IP route that shows anything about the native VLAN. You still have our subinterface IDs out here to the far right, for instance. So that's Wendell's favorite. Not that that matters for the exam, right? The second way to configure the router to use the native VLAN with router on a stick, go back, the switch is going to use VLAN 101 as the native VLAN. That's the same old config command on the switch from the previous example. We quit using the 101 subinterface, add the IP address under the physical interface, and we don't need the encapsulation command at all for this special native VLAN. Yeah, so we've kind of really moved things around, and just to show the rest of the config, again, there's no subinterface for VLAN 101. Down here for VLAN 102, it's the same old config. So this is what's new. So in effect, we've said, all right, we're just going to configure an IP address under the physical interface with no mention whatsoever of the interface using trunking. That's the alternative. Show IP route is different in that one IP address on the physical interface, well, its routes will show up under the physical interface in the routes, right? So that's a little different. So I think that's more operationally complex. I wouldn't pick it if I were picking, but you should probably know all of these variations in the context of getting ready for the CCNA exam. So let's talk about some of the things that can go wrong, and there are many things just because of the complexity here. So first off, and the most simple thing, is that you've got to make sure the VLAN ID settings match. So on the switch, the VLAN command, when you're configuring them directly without VTP, VLAN 101, 102, I've said it a bunch of times, but one more time. The VLAN ID on the switch needs to match what's in the encapsulation command on the router. The subinterface number does not matter as far as matching. It's the VLAN ID in the encapsulation command. Make sure those match. If they don't, then the logic will be off. Next up, subinterfaces have interface state, the two-word state that you see in the show interfaces command, like up and up, down and down, that kind of thing. So if it were to be all working here, and then you unplug the cable from the router, the Ethernet cable, of course, the physical interface is going to go to a down-down state, right? But the subinterfaces will also go to a down-down state. Now, why is that important? Because a lot of things with how IP works in a router is based on the interface state. So those connected routes, The subinterface would need to go to a down state in order for the router to then remove those connected routes from the routing table, right? Those subinterfaces are where the IP addresses were configured. So in fact, a general rule you can think of it is the subinterfaces, get this, the subinterfaces can't be better in terms of their interface state than the physical interface. The physical interface is down, down. The best these guys can be is down, down. All right? So a few more variations on that. Let's just say, hey, everything's working and we get into config mode on the physical and we use the shutdown command to administratively disable the physical interface. You guessed it. The subinterfaces can't be any better than the physical, so they're all going to end up administratively down and down as well. Now, the reverse logic, subinterface versus the physical, is not true. It's where you can individually manipulate the subinterfaces. For instance, let's just say you got into config mode for the .456 subinterface, the one that's associated with VLAN 102, and issued the shutdown command there from a starting point with everything up and working. Then the physical interface would remain up, the other subinterface would remain up, but this .456 subinterface would now be administratively down and down. So in effect, you could turn off each subinterface independently. Here are a few other things to check on. Output on the switch. This show interfaces trunk command is very interesting. You want to look at the output related to the switch's interface. It needs to trunk. And not only does it need to trunk, it needs to support the related VLANs all the way through to this bottom list. You can think of this output as having 3 lists in it. And I'll highlight this one. This is the list of VLANs allowed on the trunk. And then those allowed also active in this domain, and then also in spanning tree forwarding and not pruned. So basically it's progressively more restrictive. And if we're setting up ROAS on router R1 for VLANs 101 and 102, we need to see them in this third list. That's the short version. If you do this show interfaces trunk command on the switch and don't see VLAN IDs 101 and 102 down here, then that means this switch is not going to forward any receive frames or send any frames out in those VLANs because it's not in this last list, and so traffic can't flow. Now, what can cause that? Well, the biggest culprit is this first list, VLANs allowed. You may not recall it, but there's a way to configure a command on the switch and remove a VLAN from the allowed list of VLANs on a switch. That would be kind of dumb to do. But, in the realm of exam questions, they could do that in a config and remove VLAN 101 from the allowed list over here. It wouldn't show up here, it wouldn't show up here, it wouldn't show up here, and it would break this routing using router on a stick. All right, so watch out for that. It's something good to check in real life as well. Another thing that's easy to do anytime you mess around with native VLANs, but here's a case where you are, is mismatch native VLANs, and that can let a frame hop from one VLAN to another. So if I just highlight a little bit of the config, if we say kept the default native VLAN setting on the switch, which is VLAN 1, and configured, and we said, oh, Wendell's config had that native keyword. I've got to put that on one of the subinterfaces, right? And you put native here. Well, what you've told the router is that VLAN 101 is the native VLAN. And if you told the switch, by default, that VLAN 1 is the native VLAN, so that's going to create a case where frames can hop from VLAN 1 on the right to VLAN 101 on the left and vice versa. So that would be broken. And then finally, as another reminder, you can't use dynamic trunking settings on the switch. So just to show some config to break that out, if you've got switch port mode dynamic desirable, saying that we're going to dynamically negotiate trunking, the switch will never end up in a trunking state. It'll be an access port because the router doesn't participate in the negotiation of trunking. Thanks for sticking around to the end. Let's get you ready for the exam. So, Chapter 18, Section 1 in Volume 1. The section's not actually titled Router on a Stick. It's got a more formal name, but that's what it's about. You really could get away with skipping that if you want to pick up some speed. But in particular, there's an example with the show VLANs, plural, command output. It's just a lot there. it's worth reading through that, making sure you understand the output versus the example. Or it's got different examples, so a lot of times people enjoy looking through those for a second look, if you will. Next up, practice for yourself. Go to my blog, find this configuration lab. As always with these labs and many other review things, it's better if you space out your reviews. So if you're not going to do it unless you do it right now, do it right now. But it's better if you'll give it a day or two before you do it. It's best if you'll schedule it in your calendar so that you don't forget to do it. I've actually got a pair of videos associated with this one. There's an intro video to help you understand the environment. By the way, the environment is shown in the left-hand part of the figure here, where we've got 3 VLANs at the bottom of the figure and ROAS on this link between R1 and switch 1. So an intro video to set up the lab, and then a video to review the results and how to configure. Practice, practice, practice. And to that end, I made a packet tracer file that matches the examples that we've been using with this same router interface 000 with the sub interfaces. Now, you can pick whatever sub interfaces you want, but to make it work with the switch configured with VLANs 101 and 102, of course, you're going to need to use those VLAN IDs. And by the way, I think I set up passwords in there. So all the passwords, all lowercase Cisco. Hey everybody, thanks for sticking around. There's a lot of content in this one, right? If you're new here, please, of course, subscribe and click a bell so you'll get notified of new videos. I think many of you come back that are already subscribed, so thanks for doing that. Thanks for supporting the channel. Give me a like, give me a comment, let somebody know about what's going on here if you want to help me out. Thanks, y'all. Talk to you.